uh, that hand coming from that ammeter connected to my standard resistor. You can see my standard resistor here. That same hand, that resistor is parallel to my voltmeter. We can see it's parallel to my voltmeter. Hello everyone. Welcome to your physics classroom. I am Lawal Aletuni, your physics tutor. Welcome to your physics classroom to our returning viewers. To our new viewers, welcome to physics classroom. Please do well to press the subscribe button, turn on your notification button, press the like and share button, and put your comments in the comment box. As we have all known that physics practical will soon be written, and we have released a lot of videos on physics practicals. We have released videos on mechanics, we have released video on the lights, and likewise we have released videos on electricity. So this moment in this video, I'm bringing again to your screen another video on electricity. I'm making a reference with WAS 2020, why 2020, that's where I'm bringing my reference. Physics practical question 3 electricity reference WAS 2020. I have my circuit diagram on my board, and I have the instructions I want to follow before I come and show us how I did my connection. In brief, they said I have my circuit here, I have my ammeter, I have my resistance box, I have my key, I have my the battery, I have my standard resistor, that is 2 ohms, and I have my voltmeter here. Everything well connected in the circuit diagram on the board, and likewise I'll show you how I also place it on my table here. Now here I said the first instructions there according to that question said measure and record the EMF of the cell. We have known that anytime we are writing practical on electricity, the first thing we must do is that we must know the EMF of our cells. Why? Not all EMF of a cell or a battery is 1.5. I'm talking about one battery. What about if it has been used? That's why we need to know that one through our voltmeter. So the first thing we measure and record our EMF of our cell. You will also see my own when I start my own experiment as well. And number 2, they said I should set my resistance box. I should set my resistance box to 1 ohms, close the key, read and record the current I and corresponding voltage V, telling you that in this question I will need coulomb for resistance or resistor, in here you call it the value of resistor, that is R. I will need coulomb for R. I will need coulomb for the current, which is I. I also need the coulomb for voltage. They tell you that I need IVR or RVI, and I call it, that is the family of Ohm's law will come together in my table. And likewise, instruction 3 said I should repeat the procedure for 4 other values. For R equals to 2 ohms, 4 ohms, 6 ohms, and 8 ohms. That is, my first ohm resistor to be measured will be 1 ohm, followed by 2 ohms, followed by 4 ohms, 6 ohms, and 8 ohms. And before I continue, let me use this medium also to appreciate our professional colleagues from other places everywhere in the world, that we really appreciate them for all those comments and all those love and advice we do give ourselves. Thanks for being there. Alright, instruction number 4. In this case, read and record I and V. Your I is the current. That is, you measure your I on the ammeter and you measure your volts on voltmeter. That is your V. And the next procedure, that's number 5, says tabulate the readings. Remember, we have said it earlier that this table, with what they have said, that is, you need 3 coulomb. A coulomb, we need a coulomb for resistor. We need a coulomb for voltage. We need a coulomb for the current. That is, we need coulomb like that for individual. We put in their ohms there. All these things we are going to talk about them. But then I'll also show us how the experiment will be, how it can be connected. I've shown it on the screen on my board. I will also show you also physically. Alright, tabulate the reading. That is, we have something like this as our table. Plot a graph of V on the vertical axis and I on the horizontal axis. That is, they are bringing out Ohm's law. We want to detect the resistor. That resistor that we are fixing, the Ohm's law, that's standard resistor. Now leave that side again. They said determine the slope S. That's what that graph is talking about. And lastly, state 2 precautions taken to ensure accurate result. Now let me show us all these things on my table. The first thing there is to determine the EMF of the battery or the cell we are using. let me show you
Before you
how
can do
I
any
measure
practical
my
electricity, the
EMF and
first thing
how
you
we
must do
use
is
it
to
to run
detect
experiments.
the EMF of your cell. And here is my voltmeter to record the EMF of the cell. We can see that the EMF of this cell I'm using is 2.5.
Now, yes, thank you. Like I said earlier, that I will show you how I did the circuit diagram. Now I have my resistance box here. I have my ammeter. Resistance box is connected to the ammeter. The ammeter we are told to use in the Neco is the range of 0 to 2 ampere. But currently, the ammeter with me currently is one that range is a dual, one that range from 0 to 3 and one that range from 0 to 5. The one that range from 0 to 2 is not with me currently, but the next video I will make it available. That hand coming from that ammeter connected to my standard resistor. You can see my standard resistor here. That same hand, that resistor is parallel to my voltmeter. We can see it's parallel to my voltmeter. Now voltmeter also that they ask us to use is 0 to 2 volts. Or here I have 0 to 1 and 0 to 3 the dual. That is the ammeter for 0 to 2 and the voltmeter for 0 to 2. In my next video I will show that. But yeah, I just want us to see how calculation can be done on this particular topic, or this aspect of the physics practical Neco 2025. What you want to talk about there is all about Ohm's law. Now, carry that hand from both the resistor and the voltmeter, they all met at the negative side of my battery, of my cell. You have seen that when I was measuring my voltmeter at the EMF of my cell, I measured 2.5. I measured 2.5, I think I remember. I measured 2.5, I think I need to write that one down. That's my EMF, my E naught. My E naught, you say E naught or EMF, I mentioned 2.5 volts. Now, so leaving that side, and you can see my key. This key open and close. Open when the circuit, when the reading was it's not taken, but when I want to take the reading, I will put it there. Please take notice of this one because of our practice. Our precautions. So without wasting time, now let the reading start quickly. The first reading here says that when the so I'm going to see clearly when the resistor, yes, to make it sweet. Let me prepare my table so that I'll be filling my readings without wasting time. Okay, let me use this environment for my reading. I will soon stand up, but let me just make this my reading. I have my R in ohms. I have my I in ampere, and I have my volts in voltmeter. So I have the first one, is it 1.0, I see 1.0, 2.0, 4.0, 6.0, and 8.0. Now the measurement we start, the readings we start, and the experiment is start fully now. Let me start. The first measurement is to take 1 ohms resistor. Where's my marker? 1 ohms resistor. Okay, my marker is here. 1 ohms resistor. I want to take away 1 ohm resistor now from I'm taking my 1 ohm resistor. Now let me plug this. What am I going to see? So on my current, I'm seeing 0.4, seeing 0.40, and on my voltmeter, I can see 0.60. I can see 0.60. So now I don't want us to waste time. I'll go to the next measurement. Right, picking up my next measurement to measure 2. I want to take my 2. I'll replace the 1. I'll pick up the 2. So picking up the 2, you can see I have picked up my 2. So now I want to close the key for you to see what I'm going to get. On my current, I can see 0.38, and here I can see 0.56. Alright, because of time, let me make it fast. I'm going to 4. Unfortunately, there is no 4 here, so I'll pick up 2, 2. I'll pick up 2, 2. So now I have 4. What is it reading? When I pick up 2, 2, I pick up 4. 4 is giving me 0.36. 36, and my voltmeter is giving me 0.50. 0.50. Okay. Alright, I move to the next one. 6. How can I get my 6? We can manage to get 6. That is 5 plus 1. So let me replace all these 2, 2. So I first pick up 1, and I pick up 5 to make 6. And my measurement I'm seeing here, okay, that is 0.3. The measurement I'm seeing right now is 0.34. While for the voltmeter, what I'm seeing right now for the voltmeter, I'm seeing like 0.4445. Okay, 45. Say 45. Okay. All right. Let's go to the last one. 8. Now, how can we get our 8? We are going to use 1, 2, and 5. 1, 2. 1, 2, okay, 5. I already have 1 and 5. Let me add 2 to it. 1, 2, 5. That is 8. So what will now be the readings? Now that's all to check right now. What will be the readings? Here I'm seeing 0.30. I'm seeing 0.30. I'm seeing 0.4, 0.30, and I'm seeing 0.40, and that is how we finish the experiment. That's how we finish the experiment. Now I think we should go to the next video. That was in time. We want to plot the graph. The cell should plot the graph of V on the vertical axis, I on the horizontal axis. So we move by magnitude. Like I said earlier, we have the videos that we are going to produce for this particular table of value. After this video you are watching, the next video is the graph of this table itself. But in this video, we are going to sketch it. So we have the title. The title said, you see the title in the question, graph of V in volt against what? Against I in ampere. The next will now be our scale. You will talk about your scale, but my own scale that I will use, because I will use 2. I will say on vertical axis here, I will use 2 centimeter. I will say on V volt axis 2 centimeter to represent what? 0.1 volts. And for my, what do you call it, vertical axis I will say on I axis. On I axis, remember I told you in the next video, I'm going to plot this graph to you very well for you in the next video. You're going to see the next video. But this time around, I want us to sketch it and make sure that we have done the teaching, not the graph. So we have 4. I'm using 4 centimeter to represent 0.1 ampere. So how will the graph look like? The graph will look like something like this. I will have my volts here. I and we have my I here. So if you can watch very well, the voltage is dropping, the current also dropping, telling that they are directly proportional, obeying Ohm's law, state that the steady current passing through a metallic conductor is directly proportional to potential, that this current is directly proportional to the volt. They are moving in the same direction. So we are, at the end of the day, I'm going to have a graph that is directly proportional. With my sketch, maybe the V2 somewhere here, my V1 will be somewhere here, and at the end of the day, I will have it in the portion of I2, I1. You know, this is my E0. My E0 must be our top of my table. You know, my table is supposed to be at top, but because I was sitting down, that was why my table is here. Alright, at the end of the day, I will be saying my slope. I want to bring out my slope. Make sure your slope is very big for examiner to see. So I will say my slope. You know what slope means? Change in vertical over change in horizontal. That is my change in V over my change in R. And at the end of the day, your unit will be volts per meter. Not ohms, please, not ohms. It is volt per meter. Don't judge your mark by yourself. Let the examiner judge. Your own is volts over I, V over I, and the answer is volts per ammeter. Volts per ammeter. Now let's take an instance. I want to just sketch, like I said, this is my V2, my V1, my I2, my I1. How will it be? Let's see how this slope will look like. I'll be having 0.60 minus 0.40 over 0.40 minus 0.3. If you like, you can do your own anyhow, maybe this minus this over this minus this, you still get the same answer. So at the end of the day, I'm having 0.20 over 0.10. With the help of calculator, that was supposed to give me 2 volts per ammeter, and that's how I get my slope S. The slope S, I think I have done justice to that in the action of sketching. I will also plot the graph. When I also plot the graph on the in the next video, which is graph, you also see the same thing. Alright, leaving that side, I have justified the issue of plotting graph and determining the slope. The next thing is to state the precautions. What are the precautions that we need to take, or that I took when I was carrying out the experiment? You saw me very well. I used battery. So in that situation, I have a precaution on battery. I ensured that my key was open when the measurement was not taken to avoid the rundown of the battery. You saw that. I used voltmeter. What is that one talking about? It's talking about error due to parallax. That is, I avoided error due to parallax when taking my measurement or readings on voltmeter. Same thing on ammeter. And I also ensured that my wires are tightly connected. I've mentioned like 4 precautions. So all these are the precautions you gather up together to gather your mark. Like I said, if you check very well as well, we have achieved what they want us to achieve. Remember, you may wonder, I get my slope S as 2 volts per ampere, and remember my unknown resistor is 2 ohms. That is what they wanted to determine. And luckily, I got the same thing. I got 2 ohms. That is, I got 2 volts per ammeter as my slope. I think that one settled the issue of graph and the issue of slope. Before I will call it a day in this video, like I told you, please do well to watch all our videos on the physics practical, chemistry. We have done chemistry, even with the examination on chemistry has also been written. We have released a lot of videos on mechanics. We have released like 2 or 3 videos on mechanics and including the graphs. Same thing, we have released 1 video on light and the graph. And this electricity I'm doing right now is the 2nd video on electricity. Please do well to watch our playlist, check our playlist very well on our first channel and our 2nd channel. Please do well. Our first channel at Estimator Adetunji, or you can also call it Estimator Adetunji TV, and the 2nd channel that we call at Estimator Adetunji Edu Consult, or you call it Estimator Adetunji Education Consult. You are saying the same thing. Please do well to watch all the playlists there on all our practicals on physics. Biology has gone, chemistry has gone, physics also will soon be on. Let me just say that. So here I'm rounding off gradually for today's this video. So I'll be waiting for you in the next video. Our new viewers, anywhere you are watching us, please do well to turn on your notification button, because we always release video and you'll be the first one to see our video. Put your comment in the comment box. I'll be expecting the next video. Bye.